Good afternoon, everyone. Welcome back to Tech Talk Tuesday here at Treadwell. Edward Titley is my name. If you're joining us for the first time, welcome. And if you've joined us before, welcome back. Today, we are going to have a bit of a quick look through handrail brief design and some testing requirements as per AS1657. Get asked about this sort of thing quite regularly from our clients. And while this whole presentation is not only about testing, it's about some design criteria as well. Hopefully, it's just a quick insight into the standard and perhaps a quick refresher for those who are more familiar with it to cover off on a few key questions that we often get asked as far as what we do here at Treadwell. So a little bit of basic housekeeping first. Obviously, we're not Standards Australia, so I can't tell you what they meant when they worded something a particular way or anything like that. And this is obviously general advice, not site or project specific advice. So take it as such. And if there's something you'd like to discuss specifically around the project, just let us know. More than happy to set up a time to visit your site or Teams meeting or whatever you like to run through some project requirements. So a very quick overview before we start. What is AS1657? So AS1657 is a standard that gives us guidelines around design and installation of fixed platforms, walkways, stairways, and ladders. So this is not public walkway or boardwalks or that sort of thing. Boardwalks should be AS2156. Public walkways typically AS1428. This is back of house maintenance type stuff. So it could be rail stabling yards. It could be access in a sewage treatment plant for personnel. It could be on a mine processing site. Something like that. So something not accessible to the public is typically what AS1657 is applicable to. Now, FRP handrails, Treadwell offers a bolt-together modular, no-weld FRP handrail system. FRP is a composite material, so the two main constituents to that product are the glass as a reinforcement and the polymer part or the resin as the matrix or the binder to hold the product together. Obviously, metallic handrails have been used for many years in the industry. In some applications, they're absolutely a very appropriate choice. But where we see clients going to FRP is two main situations. One is a corrosion aspect, really not getting satisfactory durability from your traditional metallic handrails, and then trying to go down the line of blast and paint specs and getting a good quality coating on the handrail and on any infill mesh or screening or anything like that, which is a whole bunch of added cost. And the second thing is conductivity. FRP is naturally non-conductive, so takes out a significant chunk of earthing and bonding requirements in substations, the rail corridor, those sort of applications. So AS1657 on handrails. Now, I'll just point out this, I'll just mention at this point, we're talking about handrails. Now, when we talk about handrails in the general market, I guess in our general line of work, most of us talk about handrail. Now, this is referred to in the standard typically as guard railing, with the handrail being a single rail in a stairwell, concrete stairwell or something like that to provide a grab for your hand. So what we're talking about here is labelled by the standard as guardrail, but we'll continue to refer to it as handrail for the purpose of this presentation, just to ensure that everything is easy to follow or clear. So where is guardrail required? First, or a couple of points here. According to the standard, handrails or guardrails shall be installed on exposed sides of platforms and landing, except for the following. One is probably a pretty obvious one, which is points of access from a stairway or a ladder. And then other locations where there's a permanent structure not more than 100 mil away from a platform, or on the sides or edges of a platform that is not more than 300 mil above an adjacent platform or floor. So there's really a very minimal fall risk there. The height of a handrail above the floor or the nosing of a stair tread, so the very frontmost point of a stair tread, shall be between 900 mil and 1100 mil, where fall from height is significant, the standard suggests we increase the height to at least 1,000 mil. Where we're providing a circular metal handrail, the external diameter shall be between 30 mil and 65 mil. So that's outside diameter. And where we're using a square or rectangular handrail, the sum of the height and the width shall be between 70 mil and 100 mil. There's a diagram in the standard that gives a little more clarity around that. But for the sake of brevity, we haven't included that here, but you can jump on our website and find under resources previous webinars, including one in which we have gone through that those details in more detail or more thoroughly. Another question we sometimes get asked is around, can I have just a top rail for my handrail? Well, and obviously you can have anything you like, but the top rail only handrail is not compliant. One or more intermediate rails needs to be included. So handrail requirements, firstly, obviously we have our top rail parallel to the floor or on a sloping walkway parallel to the slope of the walkway, which is supported by posts at necessary intervals to meet the specified imposed loading actions. We'll have a look at those in due course. And then one or more intermediate rails that are parallel to the top rail space, so the maximum clear space between the rails does not exceed 450 millimeters. And then lastly, or back on that, just on the previous point, that could mean that more than one intermediate rail is required to meet that stipulation of the maximum clear space not exceeding 450 mil. And then a toe board system, if there's no permanent structure within 10 mil of the edge of a walkway, or if an object could fall to where persons have access to the area below. So we might have an elevated platform with a walkway or access underneath, and we'd need to ensure that something can't get kicked off the edge of the platform and cause an injury to someone walking underneath it. There's also, and we've mentioned this in a different webinar, also around a dropped object as part of that elevated, or that clause where persons could have access to the area below. There's a requirement that a 15 mil drop ball doesn't pass through the mesh. That's once again not strictly handrail relevant, just on the way through. Now some testing requirements. So this is seemingly an area of confusion or lack of clarity for a lot of people around. We often get asked questions along these lines. So Appendix A of AS1657 provides information on minimum components and materials. So that's section sizes and materials that should be used, in a nutshell, should be used for edge protection. Where the components are not any of those items, and we'll look at those tables shortly. So any of your, should I call them, proprietary handrail systems, like our Raylex system and like many other systems on the market, some made from steel, some made from aluminium, some made from stainless, a variety of different handrail systems. Any proprietary system along those lines has to be verified by engineering, but also tested in accordance with course 6.1, which gives us testing details. And also a couple of the appendices which mention one that's firstly a test method and a method or a format in which a test report is to be provided. So that's something that you need to be checking when we're designing, whether you're designing with one of Treadwell's, with the Treadwell's FRP handrail, or whether you're using someone else's metallic product or something that's welded on site or something like that. There's some guidelines we have to adhere to as far as what we use for the handrail. So, excuse me, this is table A1. So this is recommended minimum dimensions for typical steel components. So we have some options here for angle and flat bar for our post, top rail, intermediate rails, and toe boards. And then for the post, top, and intermediate, we have some options. Some options for a pipe as well, giving us the outside diameter and the weight of that pipe. So if we use these materials, we take that we comply with the requirements of the standard, obviously provided they're welded to an acceptable standard and so on. Now, this here is aluminium, and you'll note there's a few other details, a few more details here. Posts guardrail, intermediate rail toe board, and some details around the shape and dimensions. So we've got square hollow, round tube, rectangular hollow, and so on. I won't read the table out. I'm sure everyone's capable of reading, but this is table A2 in the standard. And then class 1 or 2 alloys, or class 2 alloys, depending on the component. And you'll note table A3 gives us the classes of aluminium that are relevant to table A2. So we've got class 1 and class 2 here. Once again, as per the previous table, anything used here is taken to be acceptable. However, note here for aluminium components, doesn't allow us the luxury, if you like, or the ability to weld, but it considers mechanical fixings only, as you can see here in this top clause. Now, now we get to the actual testing requirements. So AS1657 2018 Appendix B gives us a test method for a guardrail system, and any handrail that's not constructed of these materials we mentioned in the previous tables must be verified by engineering, and any proprietary system. So if you're buying I guess if you could call it an off-the-shelf handrail system like our Rail-X or like a variety of other systems on the market made from a variety of different materials, you need to be asking, or you should be checking with a supplier that there's a test report available to show that that testing's been done, and that's performed as per the requirements. Now, for the sake of brevity, once again, we're not going to go through every single part of the testing requirement, other than to mention a couple of things. So there's some point loads and some distributed loads applied to various regions on the handrail. So top of stanchion or post, middle of the top rail, the mid rail, the toe board, and so on. However, the point load is 0.74 kilonewtons. So at a variety of points, the test wants us to apply that. And then the distributed load of 0.55 kilonewtons per meter at various locations. And then it gives us some pass or fail criteria. So for the deflection test, which there are 6 of, I believe, from memory, deflection shouldn't exceed 100 mil. So that's deflection under load. And residual deflection, so that's deflection when the loading is removed, should not exceed more than 20 mil. And for ultimate test, the system shouldn't suffer collapse and should continue to provide restraint. However, some residual deflection is acceptable. Now, once again, a couple of things we sometimes see overlooked. One is this deflection also considers any deflection in the structural member or the mounting of the handrail. So if we've mounted our handrail to, say, PFC, and that PFC is twisting or undergoing some sort of web buckling during that loading, then that contributes to the deflection of the handrail. And if our handrail is running close to the deflection limit, so if the handrail's deflection is close to 100 mil during testing, then if there's any deflection evident in the support member, the channel or the PFC or whatever it is, then that is considered part of the deflection to the handrail, and it could render our system non-compliant. The second thing is we often have queries around the removable handrail, which is understandable why that's necessary or beneficial, but there's a couple of there's an easy pitfall with that, which is it's a very fine line between having handrail that's easy to remove, whether it's something that's removed for maintenance, or in this example here, these handrails are in some locations removed when a train's brought in to allow access to the train for any sort of maintenance and so on, and then before the train leaves, the handrails are reinstalled to stop anyone from falling from height. Now, we mentioned, as we said earlier, residual deflection not more than 20 mil. So as you'll be able to understand, if there's slot or looseness in the handrail mounting bracket, then that'll contribute to our residual deflection. Now, that means it's a fine line. I'm happy to have a discussion with anyone who's looking to do this. It's a fine line between having a handrail that can be removed easily, but also not running into issues with our residual deflection if the handrail is, for want of a more scientific term, sloppy in its mounting. I hope that makes sense. I should say, by the way, this is nearly the end of the presentation. We've got the Q&A window open. If anyone's got any questions, feel free to drop them on and we'll try and answer them either here or we'll take them on notice and address them in due course. Now, as I said, nearly to the end of the discussion, why is testing necessary? Look, I think this is probably fairly self-explanatory, but the standard gives a test method and guidelines on the format of report and so on, where we can have consistency between different products and different manufacturers, and there's a single universal method for testing that manufacturers can adhere to. So verification, quality control, make sure that we're providing a consistent product that's fit for purpose, and risk mitigation, obviously, as a designer or as an end user of a product. If you can verify that your handrail is tested, then you can be confident that it's going to meet the requirements of your project and going to keep someone safe and stock moving forward. Questions from Jeff on handrailing testing for public areas. Good question, and that's at a risk of diverting, I guess, a little bit from today's discussion, which is really AS1657 and more industrial sites. There's not, it's my knowledge that there's not a there's not a single standard given for testing for handrail in public areas like there is for AS1657. Happy to take that offline if you're looking to if you've got any particular applications or queries or anything like that. Another question that had come in as far as testing the handrail in the field, is there a simple way? Look, probably depends on what you call simple, I guess. But we have seen some clients who've made themselves a testing apparatus, which is a hydraulic ram and a load cell in a semi-portable format, which can be attached to the platform and then apply some loadings to a handrail. And they did this to ensure that their handrail, especially where there was a risk of internal corrosion or something like that, make sure the handrail was still fit for purpose and able to withstand a loading if someone actually fell or was at risk of fall. So I don't know if that's a simple way, but you'd need to find a way to test to apply a load which is repeatable or controlled with a load cell or something like that to determine the loading, and then a way to measure the deflection if you wanted to do that, or if you were just doing an ultimate test that the handrail has or hasn't failed. Another comment, the loads we've mentioned seem different to clause 6.1 in the 2018 version of AS1657. Okay, my apologies if there's a typo or something like that in there. We did get the loadings out of AS1657 2018. So if that's a typo, then my apologies. I will get that corrected if we get them before we formalise this or publish this video. Thanks for drawing that to our attention. Another comment, glad the presentation was concise. I think it was worthwhile. And a question from Robert on the beachfront. How do we overcome corrosion of the fixings, or do we use grout or socket methods? Look, that's a good question. Number one is use corrosion resistant fixing. So that might be 316 stainless at a minimum. Could be 22, some more sort of exotic stainless as 2205, 2507 or something like that. Or the second option, as you bring up very rightfully, is a socket type method where we do a board pile, a board penetration in concrete footing or something like that, and we use ground or a socket. We do an in-ground sleeve which can be cast into concrete for to facilitate the easy installation of a handrail in concrete. So that's typically how we'd address that, is, as you rightly say, some sort of grouted or epoxied in method, or you can can go to a corrosion-resistant bolt, but as you would know, everything is subject to some sort of corrosion. Another question: when installed, if the handrail deteriorates over time due to exposure or other factor, if the handrail exceeds deflection, it should be replaced. Yes, that would be right. We have had some clients have had a client, won't mention their name here, but a client with a quite corrosive environment who's used their FRP handrails, and at 12 years of age, they took some sections out and sent them in to get tested just to verify for themselves, I should say, that they were still fit for purpose or able to withstand the loadings and within the deflection criteria, and they were, so they've reinstalled them. And at such time as they feel they need to test them again, they could do that. And that might link a little bit or tie in a little bit with the question or the comment we had earlier around testing in situ. But you're very correct. If there's any deterioration of the handrail due to corrosion or maybe some sort of impact that's caused some damage or something like that, if the handrail exceeds the deflection limits, then it would be deemed to be non-compliant, and then on that basis, you'd want to look at replacing it. Looks like that's the end of our questions. So thank you very much. And once again, thanks, Anton, for drawing that to our attention. If there's a typo, I'll get that fixed. Appreciate you all joining. And we'll look forward to seeing you again in 2 weeks. In the meantime, if there's any queries that come up, drop us a line, hello@treadwellgroup.com.au. Happy to answer any questions you've got, or give us a call, 1-800-246-800 for Australia and 0800-244-600 for New Zealand. Thanks again for joining, and have a good rest of the day.